And as we look at this one, this was a bike bought on eBay. And what we see here, and the first thing is the camber, which would be the lack of perpendicularity between the swing arm pivot and the steering head axis. We see that this is a positive 0.24 degrees, or 2400ths of a degree. Looking at our chart down here, we see that positive would be represented by, from the rear of the motorcycle, being a clockwise view. So we see that it's 2400ths of a degree that way. Allowable tolerance on something like that is 0.3 of a degree. So that's just barely inside of what we would consider maximum allowable tolerance. The next thing we're going to look at is the steering head angle, and we have it called out at 25 degrees. And of course, this is not 25 degrees on the bike to the road plane. What this is that we know that at 947 millimeters from the center of the swing arm pivot to the bottom of the bearing cup, and from that dimension vertically up 401 millimeters, we know that at those two coordinates, that steering head angle should be 25 degrees. This bike was measured at 23.77, or 1.23 degrees short. So that's going to be steep, and that explains why there's a little bit of chipped paint and things of that nature by the steering head. The next thing we look at is that this distance from the center of this to here should be 947.2 millimeters. It is 945.7, so we're just over 4 millimeters short, which would sort of make sense. And then when you push the steering head in, it tends to rise up. So that's why our B dimension is long. And so that's what's going on here, and it all sort of makes sense. We see that our swing arm is just fine. We're negative 1.1 millimeters, so it would be to the left as far as our lateral offset goes. Our offset of our rear wheel is 2.1, which means the whole bike is within 1 millimeter, because it would be 2.1 the same way as this is 1.1, so it would cancel itself out and be 1 millimeter over. 1100ths of a degree, we're just fine with that. We've got a little bit of a trouble with a misalignment on that, and we'll fix that later for him. That's what we're seeing, so that's what we're going to do. In case you're interested, I'm going to go through the math on this with you. To be able to tell a customer how much 1.23 degrees is, you have to get a scientific calculator, and what you would do is hit sine, and then 1.23 would be the number that we got from the max system. In this case, it's positive, because what's the sense? Then that would give us our factor. That's how many thousandths it is per inch. On that Harley Davidson there, from the contact patch of the tire to the top of the steering head is very close to 40 inches. So if we multiply this by 40 inches, we get that that bike is 858 thousandths of an inch behind where it should be. So if we take our caliper, this is a handy tool for showing people, and we stretch this out to 858. So 858, that's how far back that tire is, and that's certainly something that needs to be fixed. Okay, so that's how you would do that. So it would be sine times the number that the max gave you, and then you would multiply that by the distance from the top of the steering head to the contact patch, and that would give you the total amount in thousandths of an inch. Okay. So I'd like to talk to you for a moment or two about tooling. This is kind of an interesting setup that we have here today. This would be the tooling for a normal, straightforward GSXR. This is actually a GSXR Japanese bike tooling shaft. And what we do here is typically we would remove the swing arm pivot. This would be inserted into the swing arm pivot. This would be threaded right into the frame. We would torque this so that this would have 15 foot-pounds of pressure on it, just like a normal, when the swing arm pivots in the bike. We would put this end and this end into the tooling on the jig, center it up, and begin to straighten the bike from there. On this Harley Davidson, since it's rubber mounted, and what we mean by that is back in here, you can't really see it right now, but back in there is a elastomer cup that fits into this boss here. And here is your locating hole. And what happens is this goes onto the frame and picks up into this bolt and this bolt. And here's the bolts that normally go in it when it's in the motorcycle, on the top and the bottom. Since this bike doesn't have a swing arm in it per se, our dimensions for this motorcycle are predicated on using this bolt here. That's why, me being incredibly ridiculous as I am, I've gone through the trouble of putting a center in here, and I have a spare set of bolts that I keep in my kit so that when I do go to measure a Harley-Davidson on site, I just change out these bolts and I'm sure I'm absolutely in the center of this. So what I've done for this tooling is I've built a spud on here, so this is able to accept the tooling holder on the jig. And then I've milled, if you see the top of this is one of these things that's been milled in half. And the reason I've done that is so that it holds the elastomer, rubber, however you want to say that thing, the piece that locates the engine and transmission is still being held in place from this piece of tooling. I have my adapter to the jig put on top of there. So this is the hole that I'll use to measure the bike while it's in the jig. And that concludes the tooling on the Harley-Davidson versus the tooling on a regular, straightforward Japanese bike or a conventionally built bike with a swing arm. So what I'd like to talk to you now about is the front tooling, or the tooling for the steering head, and the way that it works. Basically, this is obviously the steering head of the motorcycle, and I don't think you can see it, but right in there is part of my bushing. And there's also one right down in here. So what I've done is this is a needle steering head bearing that was pressed into the steering head at the top and at the bottom. And what I've gone ahead and done is I've removed these out of the bike, and then I've put a bushing in. This isn't the right ID, or OD for that matter, but what I've done is I've gone ahead and I have a set made up for this bike, and I've pushed this up into the steering head to where only that much of it's showing. And then the inside of this hole is the same inside diameter as this shaft. And so what that's allowed me to do is put one of these at the top, one of these at the bottom, stick the shaft through, put my spacer down here at the bottom, which gives me a mechanical advantage as far as stretching out the neck goes, and it decreases my pressure needed to do that. And what I'm able to do now is put this shaft concentric to the steering head, put my little cheater on there that increases my leverage, and then I'm able to build up the bracing that allows me to pull. I'm going to pull this out, that 1.23 degrees that we've talked about, and almost as importantly, I'm going to be able to hold the top of this, right? That way we don't just pull the whole frame forward. What we basically do is pull an angle into it, because we're 4 millimeters short, we're not 15 millimeters short, so we just need to pivot the steering head axis, and that'll give us our 4 millimeters at the bottom. So the next shot you'll see will be of the bike in the jig, and we'll talk about centering it up in the jig, and we'll begin to straighten it. All right, so the bike, as you can see now, is in the jig, and what's left to do is to get an equal number on this scale here from this red line here, which will tell us where the bike is perpendicular. And then what we need to do is, if you see this scale underneath here, there's also a line under here that we're going to need to read, so that we ensure that we have the bike in here centered up and forward enough for us to do the pull. So we're going to go ahead and do that now. Okay, so I'm at 275 on this side now. When I look at this side, I'm at 275 and a half. So what we're going to do is we're going to go ahead and tighten this up at this point, and we'll have the bike locked in this axis.